All right, let's explore the two cornerstone concepts, object-oriented programming, inheritance and polymorphism. At its core, inheritance allows us to create specialized classes that inherit fields and methods from a parent superclass. We use the keyword extends, which lets a subclass take everything from a superclass and then add new features, or override existing behaviors when a subclass wants to provide its own specific behavior. It marks that method with the override annotation. This brings us directly to polymorphism, which literally translates to having many forms. In programming, polymorphism means a variable declared as a general supertype can hold any subtype object, and the runtime environment automatically executes the correct overridden method. This powerful idea is what lets a single array list of shape hold circles, squares, and triangles together, accurately calculating the area on each one without manual type checks. Let us look at the code on your screen together line by line. At the top of the file, we define our superclass by declaring public class animal inside this class. On the next line, we declare the public speak method, returning a string. In the body of this method, we return 3 dots as a string literal. This provides a general default fallback implementation for any generic animal in our system. Let us look at our first specialized subclass, the cat class. On this line, we declare public class cat extends animal. That keyword extends explicitly establishes the inheritance relationship, making cat a subclass of animal. On the next line, place the override annotation. This explicitly tells the Java compiler that we are replacing the superclass version of this method with a more specific implementation. Right below that, we define cat's own version of the public speak method. Inside its method body, we return the string literal meow. The cat class has now successfully overridden the generic speak behavior with its own specialized sound. Let us see how we instantiate this cat object using polymorphism. On this line, we write animal A equals new cat. The reference variable A is typed generically on the left as an animal, but on the right side, the actual object instantiated in heap memory is a cat. On the very next line, we call a dot speak. Look at the comment beside it. It returns meow by running cat's version of the method, even though variable A is typed as an animal. Let us slow down and walk through a second subclass example together. Creating a dog class using this exact same pattern. Imagine we write public class dog extends animal. Just like with cat, dog becomes a subclass, inheriting all the basic structure from animal. Next, we add the override annotation right above our method declaration. Then we write our method header public string speak. Inside the method body, this time we return the string literal bark. By doing this, our dog class provides its own unique sound, overriding the general animal behavior. Now, let us instantiate this dog object polymorphically. We declare our variable by writing animal B equals new dog. Look at the types very carefully here. On the left side, our reference variable B is typed as an animal. On the right side, the actual object sitting in memory is a dog. When we call b.speak, the Java virtual machine looks at the true object type on the heap, sees that it is a dog, and runs dog's version of speak. It produces the string bark dynamically and cleanly. Both A and B share the common animal supertype, but each one behaves according to its true underlying instance. Take a moment to trace through these lines on your screen, and we will look other concepts and facilities in the modern language next.